Ben Pierce on the Rosa Tracker. We had on our video the discovery of a mega comet, a 150 to 200 kilometer wide rock that is full of ice and ammonium that's coming close to the orbit of Saturn. And at that orbit, it's able to melt and form a little bit of a tail, making it the largest comet that we have ever discovered. It's not much of a comet. It's got a really hard name to pronounce, Bernardinelli-Bernstein or something like that. I really should have had that in front of me. But it got people asking, and I saw this question on Reddit, what is the largest a comet could theoretically be? And a lot of people were like, well, there's no definition that could possibly satisfy that. But I started thinking about it. What makes a comet a comet? And the distinctive thing is that it has a tail made out of water ice, and then it has an eccentrical orbit that will bring it close to the sun or another star, presumably, and then back out. And if you have that feature, then you have a comet. So let's look into what it would take. The bigger an object you have, the less comet-like it's going to be. Earth is not a comet because we have all of our water vapor. It still stays on Earth. It doesn't melt. And also it doesn't have the eccentric orbit. But even if you were to bring it around, it's just too big. You would melt the oceans, but you wouldn't form a cometary tail. So therefore, the Earth is not a comet. Saturn is also not a comet. It has a very, very low density, but it's quite huge. And even if it were to be brought close, it would also not be a comet. So there's some size limit, and it's a little bit tough here because the density is important. Let's take the gas. We're saying water vapor just for simplicity's sake. Which gas you depend on makes a huge difference. There's very, very little hydrogen and helium in the atmosphere of the Earth. All of the hydrogen has gotten trapped up into water and other such hydrochemicals, but the helium will just escape out because it doesn't form bonds very easily with anything. Theoretically, you can form some, but we're not going to go into chemistry in this video. The helium will tend to escape out of the atmosphere because it is so light, and because of the ideal gas law, the vibrations are heavier for lighter elements. Pressure times mass times volume equals, I can't remember it. But the lighter that an element is, and hydrogen is pretty low, but helium is there, and hydrogen tends to form some kind of reactive thing. The helium will leave the Earth, and this depends somewhat on the temperature and the pressure. There's a nice little chart here that we can see exactly what these temperatures are. Now, this chart is meant over geological scales. A comet, though, is not a geological event per se. It happens relatively quickly. So these limits don't really make sense. There is a distribution of speed of particles that happens in, I forget the name of the law, the something Boltzmann law, I want to say, has this distribution. So I'm arbitrarily going to say that if 80% of the particles stay, 20% of them have a high enough velocity to leave, then it'll form something of a cometary tail. Now, that's pretty arbitrary, but let's just go with this. Therefore, you can have a relationship where if you know the density of the object, you can scale it up and you can see at what point in time will the gravity be such that the escape velocity for this particle is too high, that it's just going to leave. And as we play around with this relationship, let's look at the Kuiper Belt objects because, quite frankly, that's going to be the largest comet. The density of the larger of these is approximately 2 grams per centimeter squared, which is about twice that of water. So they have some rocky parts, they have some water. If you scale that up, then the size that it takes to form this tail using all of these predictions that we have made, and probably a bunch of other stuff. I'll leave the full description of my thought process below, including some links to some handy calculators. It turns out that about 600 kilometers, which is about 400 miles, roughly off the top of my head, is the maximum size of a comet. If you get to be anything bigger than that, then it's going to hold in the water vapor, so even if it passes close, it's just going to melt. It's not going to form this nice, lovely tail. It still will form a little bit of tail. Technically, Earth has a little bit of a tail, but not anything meaningful. And sure, if you have a ginormous gas planet that passes super, super close to the sun, it's going to form a tail of hydrogen, and maybe that would be a comet. We've seen some of those actually on some exosolar planets. But I think water and dusty tails is kind of what we think of, and I think that this is a reasonable definition of what the largest comet is. Thank you guys much for joining me. Let me know whatever questions or comments you have, and let me know if you guys have a different definition of what the largest comet should be. Thanks for everything, guys, and until next time, keep on tracking. Take care.